So, hi, welcome. I thought I was already live, but actually I'm not. So I would say I'm repeating the whole thing. Hello, I'm Giuseppe Anacone from the University of Pisa, and I'm coordinating the AUTOCAPSULE project, which is the project I would like to talk about today. The project has a longer title, which is Autonomous Multimodal Implantable Endoscopic Capsule for the Gastrointestinal Tract. And it's an FET proactive project, which is going to start in November 1st and for a total of 4 years. As you can see, it's a project in the biomedical robotics space, which is coordinated by the University of Pisa, together with the University of Leeds and the University of Glasgow in the UK, IMEC in Belgium, and Quantalis, which is a small company, spin-off of the University of Pisa, actually in Italy, of course. So let me just reduce the size of my window, and let me just mention something about the background of the project and the objective of the project. We want to demonstrate the viability of a technology for early diagnosis of the inflammatory bowel disease and of bowel cancer, and for monitoring the treatment effectiveness at primary and secondary point of care. The main objective is this one is a untethered autonomous capsule that is implantable in the gastrointestinal tract for several weeks in order to monitor a specific area, but can also explore the GI tract for endoscopy in a point of care through magnetic manipulation with an external robotic arm and with limited training of the operator. And it's also capable of multimodal sensing, including micro-ultrasound imaging, white light imaging, pH and inflammation monitoring. Now, why are we so interested in this type of capsule? Actually, the gastrointestinal system is a highly complex system and is subject to frequent external stimuli through eating and digestion, and carries an extremely high burden of disease. Indeed, between 15 and 40% of the European population report functional GI conditions. So, we want to focus in particular, as I said before, on IBD, inflammatory bowel disease, and colorectal cancer. Colorectal cancer is the most common cancer in men, 30% of all new cancers. It is the second most common type of cancer in women, 25% of all new cancers. And according to statistics from 2012, there's a total of about 350,000 cases in the total EU. So we need to have clear in mind that the burden of healthcare systems is rising worldwide, with increased screening cited as the primary reason. Now, what do we plan to do? We have two approaches to our vision. The AUTOCAPSULE vision is shown below here in the image at the beginning, and is a capsule which is, let's say, something like 3 centimeters in length and about 1 centimeter in diameter. And it can be moved with a robotic arm placed outside of the patient, and is connected through a wireless link with a power transmitter and with a transceiver for data exchange. So it's completely untethered. On board, there's a lot of things, as you can see here, a lot of sensing interfaces, sensing for pH, for temperature, impedance spectroscopy. There's a micro-ultrasound array for micro-ultrasound array imaging, and a white light imaging camera. Also, the capsule has a clip to be clipped to the mucosa. And how do we arrive to this vision? Basically, we want to have in place two different paths. One of increasing complexity, the path that we call implantable capsule demonstrator, and one of untethering, the path that we call robotic capsule demonstrator. So the two paths will have each only a part of the feature of the total AUTOCAPSULE vision, so they will serve us to test all the different, let's say, functions that we need to put on board of the final AUTOCAPSULE. The implantable capsule demonstrator basically is already an untethered demonstrator. The first version, we have a battery on board, only for doing pH sensing and temperature sensing, and we'll exchange data through a wireless link. The second generation will receive power via radio waves, so with power, wireless power transfer mechanism. And we have no battery on board. We'll do also impedance spectroscopy. And then we'll arrive to the final AUTOCAPSULE that I described before. So we start with a lighter and smaller capsule, and we add at each step new functions. The robotic capsule demonstrator instead starts with the power heavy sensing mechanisms already in place, the micro ultrasound and the white light imaging camera, but will be at the beginning fully tethered. So it will receive power and will exchange data through a wire. The robotic positioning will be in place, so it will have a permanent magnet on board for the and all the electronics for the processing of magnetic sensing data on board already from the beginning. So it will be a capsule with a much higher power consumption, let's say in the order of 100 milliwatt, and then we will progressively remove the wire, and we will have the capsule fully powered through a wireless radio link, and then we will add to the capsule all the other low power sensing mechanisms. Okay, so here there is a table that basically repeats the whole thing. The thing that I want to, let's say, highlight is the fact that if you look at the ticks, considering the robotic capsule line, the implantable capsule line, and the vision capsule row, you see that basically each of the two paths corresponds to a part of the total functions that we need to have on the full vision capsule. So it's really this methodology to test separately the different conditions and to verify that we can add every function as in a reasonable way. I'd like to show you a couple of numbers that I think are interesting. Here, look at the power range. It's a very large range between 1 microwatt and 100 milliwatt. 100 milliwatt is when the let's say power hungry sensing mechanisms are used, the micro ultrasound in particular and the camera. And of course the 1 microwatt is where the power hungry mechanisms are off, and we are basically performing only temperature monitoring with a small duty cycle. The data rate we plan to reach is at the very end 4 megabit per second, and with a maximum permanence in the GI tract of 60 days. I want to stress the fact that these are extremely ambitious targets, but of course this is the nature of an FET project, and we really want to change the way this type of diagnostics is performed. Okay, we do not start from scratch. Actually, there have been partners with a lot of expertise on these issues. In particular, the UK partners in Glasgow and Leeds have already participated to a national project which is called Sonopil, which is the precursor of what we want to build today. Sonopil is a tethered pill because it's powered with wire and communicates through a wire, but already has on board radial ultrasound imaging tools and the video camera. We can, let's say, improve things because the electronics was not fully integrated, and in the AUTOCAPSULE project we plan to have fully integrated electronics. So there are there's room for improvement, and we already have, let's say, determined the spots in which we can provide the most improvement. And also IMEC has expertise in implantable capsule demonstrator fabrication. This small implantable capsule has 3 boards inside, is powered via wireless charging, has on board a temperature sensor and a pH sensor, and also can include impedance spectroscopy. So it's a very good, let's say, starting point for what we plan to do in AUTOCAPSULE. The real challenge, as I already mentioned, is the wireless powering and communication through the body, because of course the body has tissue full of water that can have a significant power loss. And so there are, let's say, preliminary studies that show that it's possible to provide power, significant power through the body, and also transmitting a reasonable at a reasonable data rate of a few megabits per second. Also at about also at a center frequency of about 443 megahertz. So this is a promising starting point for us. Of course, everything has to be checked. We plan to do experiments in vivo in the facilities in Leeds in particular, and this is going to be the real final test for the capsule we want to make. So I thank you for your attention. As the project is going to last for 4 years, so we really are looking forward to the starting of this project and to do this trip together towards the demonstration of the final AUTOCAPSULE. If you want to have more information, just reach me or check on the AUTOCAPSULE website, www.autocapsule.eu, and thanks for participating. If there are some questions, I can check on the YouTube chat, but I don't see that much now, so I can probably stop here. And of course I'm checking the comments, so if there are any I can actually reply, or just you can write back to me if you're interested. Thank you.